Welcome class to day 7 of digital learning. Yesterday, Mr. Walters made a video going over the first 4 problems of our Unit 10 practice test. Today, we are going to go over questions 5 through 8. So let's start by looking at question 5. A store clerk took count of how many pieces of candy were in each jar on a shelf. It wants us to make a histogram of the data using an interval of 10, and then provides us with a list of data. Why don't you pause the video now and go ahead and attempt to make your histogram. We have a histogram that I prepared earlier. Let's see how yours compares to mine. My histogram is broken in to 2 categories, pieces of candy and the frequency. It's broken into intervals of 10, as the question requested, 1 through 10, 11 through 20, 21 through 30, and so on. And it says that I had 4 jars with between 1 and 10 pieces of candy in them. That would account for the 1, the 6, the 8, and the 3. It then says that I have 2 jars that have between 11 and 20 pieces of candy in them. That would be the 15 and the 17 in my data set. It says that there are 3 jars with between 21 and 30 pieces of candy. That would be the 25, the 22, and the 30. And both of the last 2 categories, 31 to 40 and 41 to 50, have 1 number each, 33 and 41. This histogram does represent each and every data point in our set. So how did yours look compared to mine? Question 6 gives us a table that shows us the minutes per day that members of a cross-country team spent practicing over summer break and their mile times when returning to school the following semester. We know that based on the question asking us to calculate a line of best fit that we're going to use our technology. So right over here, I have put the steps to finding a line of best fit when given a table. You go to Stat Edit, you enter the X values of your table in the L1, the Y values in the L2. Next, you go to Stat, and you go to the right, you hit the right arrow, and then Calc, and you enter 4 for LinReg and press Enter, and that will provide you with a line of best fit. So go ahead and pause the video now and try and find the line of best fit for this data. Upon entering the data into my calculator and following the steps, I got a line of best fit of y equals negative 0.175x plus 10.9. Our question is asking us specifically about the y-intercept. I know that that's the b value. So my y-intercept is 10.9. So let's look at our answer choices. It says A, the y-intercept means that with 0 minutes of practice, the mile would be about 10.9 minutes. Well, that's true. So I'm going to circle that, but I'm going to keep reading. It's never good to stop at the first one. The y-intercept means that with 0 minutes of practice, the mile would be about 11.2 minutes. Well, I know that's not right because 11.2 was not my y-intercept, and it says at 0 minutes. So, can't be B. C, the y-intercept means that for every minute of daily practice, the mile time would increase by about 10.9 minutes. Well, that's describing slope. So I know my question asked about the y-intercept. And D, the y-intercept means that for every minute of daily, that's also about slope. Our next question asks us to describe if the expected correlation is positive, negative, or has no correlation. Gives us a number of examples. Number A, a person The height of a person over time. All right. So typically over time, people grow. So I'm going to say that the height of a person over time is a positive correlation because as time increases, the height increases. If both are increasing, it's going to show positive correlation. Next, B, students' grades in math and how many miles they live from school. All right, so I don't think that a student's grades in math have anything to do with where they live because you guys are all at school for the same amount of time. So I'm going to say that there's no correlation there. C, the number of miles walked in a pair of shoes and the thickness of the shoe's heels. Well, let's think about that. As the number of miles increases, you're going to wear out your shoe. So the thickness of your heels is going to decrease. It's going to get thinner. So if one variable is increasing while the other is decreasing, that's going to be negative correlation. D, outside temperature and the cost of air conditioning. Well, I know from personal experience that the hotter it is outside, the more expensive it is to cool down my house. So as the temperature rises or increases, the cost of my air conditioning also increases. So that's going to show a positive correlation. Both variables are increasing. E, the number of words written with a pen and the amount of ink remaining in the pen. So the more we write, what happens to our ink? The level of ink is going to decrease. So the more words increasing, ink decreasing. As one variable increase and one variable decrease is going to show a negative correlation. It's going to look like a negative slope when plotted on a graph. F, the number of groceries purchased and the total amount of the bill. So the more you buy, the more expensive it is. So I'm going to say that as the number of groceries increases, the total amount of the bill also increases. Both variables are increasing. It's showing positive correlation. G, the selling price of a calculator and the number of functions it can perform. Well, guys, a graphing calculator costs more than a scientific calculator. So it would be fair to say that as the number of functions increases, so does the price. If both variables are increasing, again, we're showing positive correlation. Our last example, number of hours spent studying and the number of hours spent watching TV. Well, guys, the more hours you spend watching TV, the less hours you have to spend studying, and vice versa. The more hours you spend studying, the less hours you have to watch TV. So that is a negative correlation. As one increases, the other is decreasing. Our last question, question 8. The table shows the number of employees in a company over 5 years. All right, guys, it's time to use technology to calculate a line representative of our data again. Again, I've put the instructions right here for using on your TI-83 or 84 calculator. Now, I'm going to pause while you find your line of best fit and substitute the year 11 for your X value or your input value. So my line of best fit that I got from my calculator was y equals 5.3x plus 15.7. I substituted 11 for the 11th year and got 74. So our answer would be B, 74.